Hi everyone, my name is Isha Chakraborty and I'm a rising senior from East Bay, California, and I will be conducting this interview today. So Humans of Neuroscience is a Simply Neuroscience outreach initiative dedicated to sharing the stories of humans in neuroscience and psychology of all ages and all educational backgrounds to showcase the amazing diversity we have in this field. We aim to inspire the future one story at a time. So today we will be hearing about the story of Caleb Shi. Caleb is a student at Harvard with a broad research interest in neurological injury and degradation. He has been a research intern at Stevens Institute of Technology and the Boston Children's Hospital. He has won numerous awards in the field, such as the AAN Neuroscience Research Award, and has a publication regarding neuroblastoma cells. On behalf of the entire Humans of Neuroscience team, I am pleased to welcome Caleb.
Thank
Hello.
you. Hi.
Hi, thank you so much for joining us. Would you like to
Absolutely.
share a little about yourself?
Yeah, so that was a pretty good introduction, but yeah, so I am a sophomore at Harvard College, concentrating in that's the fancy pretentious word we use for majoring in neuroscience. Right now with the specific focus in computational neuroscience, although that might change in the future. And yeah, like you said, um, most of my interests are in neural injury, neural degradation, but right now I'm actually working in a really exciting lab that's doing axon regeneration. So, it's kind of an interesting, it's an interesting story to be told, whereas, my previous research was on, okay, what are the molecular mechanisms that control neuronal dysfunction, while in this lab we're really trying to look at how do we get these to repair themselves after injury. So it's a really nice timeline of work that I'm looking at. So yeah.
Wow, that's really interesting. We're so excited to hear more about your journey. So the first question I have for you is just what is a little about your work in neuroscience? So you've gone over that a little bit, but anything specifically now, like any certain organizations you're working with, any labs or any work with Harvard you're doing?
Yeah, so right now I am a member of the Benowitz lab at Boston Children's Hospital, which is a hospital affiliated with the Harvard Medical School. And yeah, so there right now I'm just working on um, some remote stuff for an axon regeneration project. So we actually look specifically at retinal ganglion cells. So those are a cell type that you find in your eye. And going into it, I was like, you know, mm, I'm not sure if I want to work on the visual system, but turns out the visual system is quite an incredible model for the entire nervous system. So that's some really interesting work. Um, but yeah, like lately, due to the pandemic, I've just been doing mostly remote work, and due to institutional policy, let's say, I probably won't be able to go on site and do work for the foreseeable future. But that's a story for another time. And in the past, I worked on traumatic brain injury and finding, well, first of all, trying to simplify our existing model for traumatic brain injury, and using that simplified model to identify therapeutic targets for TBI. So that's sort of all the research I've done in a nutshell.
Wow, and that's really interesting about how you talked about, not understanding if you wanted to go into the visual aspect. So kind of drawing off of that, what drew you to pursuing neuroscience in general?
Yeah, I think how I started was it was more like the specific. So I didn't go into it being like, oh, you know what, I'm gonna do neuroscience and I'm gonna pick pick a specific field. What actually ended up happening was um, I played football when I was in middle school, and a lot of my teammates were sustaining concussions. So that's sort of how I got into the traumatic brain injury interest. So yeah, so I did that, and then I realized, hey, hey, the brain is kind of really cool, and we don't know that much about it, which is alarming, considering it is the singular thing that controls most of our actions. So yeah, that's how I essentially got into neuroscience, is just almost by accident, right? Just almost, my teammates were sustaining some really bad injuries, head injuries. So I was like, let's look at this. And so that's, yeah, that's the brief story about how I got into neuroscience. Not too exciting, I know, but it is what it is.
No, that's so exciting. You have like a major, like, story, like a leading motivation towards it. And that's really inspiring. So, kind of going off of that, what was like your brain journey? So, after high school, like, what was that journey like?
Yeah. So I went into college being like, okay, there's one of two things I would major in. So at Harvard we don't choose a major until the sophomore year. And so I went into freshman year saying, okay, I'm either going to major in neuroscience or I'm going to major in biomedical engineering, right? And so um, I think throughout the year, I took a course that focused heavily on research methods, and they were teaching us how to think like a good scientist, how to be a good scientist, right? Like how to design experiments. And one of the faculty members was a neuroscientist, and just so from that course and just looking at the research that was being done on campus, it was like, oh, I want to be a scientist more than I want to be an engineer. So that's sort of how I settled into the field of, or that's how I settled into majoring in neuroscience. Um, yeah, there's really, it's really not that exciting because I'm not one of those people that changes their major like 8 times, right? I sort of just, it seemed like the right choice for me. So that's what we're going with. Now, looking ahead to sort of my brain journey, I think I do want to supplement, right? Sort of what I'm doing with neuroscience with other fields. So looking into taking courses, in physics or computer science, or mechanical engineering, to see, because neuroscience is a very interdisciplinary subject, right? Because of its complexity. So I think moving forward, the next the next part of my journey will be expanding my horizons past neuroscience, and then coming back to it and see what other what principles from physics, CS, I can apply towards my work in neuroscience.
Wow, that's really interesting. And I liked how you talked about like Harvard in general. Like, I wanted to touch a little bit more about that. So, do you
Mhm.
think by attending that university, that has had a major impact in your understanding of the field, like in terms of where you want to go? Or do you think it was something that you kind of already had since high school?
Yeah, I think, wanting to do neuroscience is something that I've already, like, I had already, sort of thought about before going in. And, the classes that I took at Harvard really just confirmed that for me. Yeah, it wasn't, that dramatic, oh, this, that dramatic shift in interest. But yeah, I think yeah, it was really just a confirming factor for me. And moving forward, like, I'm still not entirely sure, right, what specific subfield I would like to go into, but for now, I think just having that general interest is enough.
So it's great how, you had this interest since high school and you're able to really go into this right now. But did you have any like particular obstacles you faced in the path to getting to where you are right now, whether that's in high school or even now that you're facing?
Yeah, I would say, yeah, I've had a few, mostly self-inflicted. So, one thing that I really struggled with um, in high school was not being willing to, reach out and say, hey, this, if we're talking about research, like, this data doesn't make sense. Can you look at it for me, right? Because within, the high school, science competition setting, there's always, time pressure and, a pressure to get it right. Yeah, I think the high school, science competition thing just really like bastardizes the scientific process. But as a result, I was, just like doing experiments like en masse, and I wasn't really reaching out to collaborate or to even have my advisor look it over, right? So I had some rough points with that. So I would say that was an obstacle. And also, I think sophomore year of high school, uh, I got really ambitious with my course load. So I got chewed out during a group meeting for stretching myself too thin. So yeah, I would say throughout high school, I was probably my own like biggest obstacle. And so, just moving forward in college, just don't stretch yourself too thin, and always look for help. Always seek out your advisor, or whoever else is in a position to help you, for help if you need it.
Wow, that's really inspiring, and it's nice to hear that everyone does have a few obstacles along the way. But I'm glad that you were able to really learn from that and implement that now. And so kind of going, let's like kind of moving on, but like, what about the brain like still fascinates you? So now I'm sure you've like learned a lot since like high school, but is there anything that still really makes you excited?
Yeah, I think even though now I'm working in axon regeneration, I think something that I always go back to is just the brain injury and neurodegeneration. And I just think it's amazing that the brain and the molecules that um help the brain function, it's like it's like a complex, it's like an intricate dance, really, how all of these molecules shift around and help our brain function. And it's absolutely amazing that that same you know dance of molecules can actually hurt the way our brains function, right? So I think that's incredibly interesting. And that is something that's not well researched yet, right? We don't really have a treatment for Parkinson's, Alzheimer's, or any of the other forms that neurodegeneration might take, right? And it's incredibly tragic. So yeah, I think that's one subfield that still really interests me. And recently, because of my work in axon regeneration, I think that's a really exciting field too, because that has pretty immediate um, translational benefits, or properties, I should say, because, you come up with something in the lab and then immediately you can say, oh, maybe, this can benefit patients with glaucoma or multiple sclerosis or something like that, right? So yeah, yeah, no, those are the two that are immediately pretty interesting to me, and I'm sure there's more that I just haven't had the time to read about. But yeah, yeah, and I think the brain, the interface, right, between the brain and computers is also quite interesting, especially now that we're modeling computer algorithms um, based on the way that human neurons function. I think that's really cool. But I'm not sure if I agree with Elon Musk's like thing, like he's trying to like upload your consciousness or something to the internet. I'm not sure I can be on board with that. But using computers in conjunction with principles from neuroscience is really, really cool.
Yeah, that's really interesting. And also talking about like the scope of this field, how we can go forward with this. I think that's really interesting to talk about like there's so much to neuroscience and we're not done exploring.
Yeah,
And
absolutely.
yeah, so kind of going off of that, did the complexity of neuroscience, was that something that you thought was appealing as you went into like this field, or for a lot of people it's daunting to think that there's so many different aspects to this? But did that make you scared in any way, or did that like motivate you in a certain way?
Oh, yeah, I think definitely I'm someone that's up for a challenge. So, I'm sure it was a motivating factor. But something that you do always have to keep in mind is, it is a very large, field. And, it's important to keep in mind that, you know, as a single person, you can only contribute so much, right? So, don't be worried about how big it is, or how complex it is, because at the end of the day, you'll find your niche within the field, and you'll find something that you enjoy doing. You'll find work that you enjoy doing, and you just do it, right? So yeah, I would just say it doesn't have to be daunting, right? It can be at first sight, but once you find your like little personal area of work, right, then it starts to become manageable.
And going off of that, did you have any like specific mentors or professors or anybody out there who really helped you and kind of guided you throughout the whole process, or even motivated you for that matter?
Oh yeah, absolutely. So I think first and foremost, my research advisor from high school. So if you're not familiar, my high school actually had multiple research labs built within it, and each lab had its own PI, so to speak. And so mine was um, she was named Donna Leonardi. So she was my main advisor throughout high school, and she's just like, she has a way with mentoring young scientists, and so I owe a lot of what I've done to her, and sort of her just pushing me to just do the best that I could do. So yeah, I mean, yeah, she was great. And then over the summers, when the high school was closed, I would do my work at Stevens under a PI named Robert Chang. And my research initially wasn't the main focus of his lab. He's actually he actually works on like 3D printing bio structures. But he was willing to take my project on, maybe, I don't know, because he thought it was interesting or something. And really grateful to him for letting me use up, lab resources and giving me lab space to work over the summers.
That's really nice that you had people along the way. And
Yeah.
even with having guidance and having mentors, did you face any like issues regarding like ignorance or like stereotypes throughout your journey? Or like, I mean, like, was there anything that you faced was like kind of like a roadblock in the way?
Yeah. You know, unlike most people, I would say I had a fairly, smooth sailing. But one thing that did come up, I guess, during the whole, again with the whole like competition thing is people generally weren't too uh open to my project for some reason. Maybe, maybe I wasn't explaining it well enough, but yeah, a lot of the times people would just sort of be confused, or I don't know, just sort of be ignorant about the results. And that shouldn't bother you, like that didn't bother me. It was like, whatever, I know that my work is genuine, and these are the results I get, so, think what you want about them. But yeah, that was something that I experienced, with the science fairs and stuff, is that people are so like pigeonholed into their own like conceptions of what, you know results should be, that sometimes they're not willing to accept newer results or more innovative projects.
And that's really interesting you talk about that past project. So would you like to tell us a little about this? Because we've been discussing it, and I feel like we should maybe like go more in depth about this because it seems like it was a really big motivation in your interest.
Yeah. So essentially, what the project was for, phase one of the project was, can we construct um a cheaper and more simple model of the, you know traumatic brain injury microenvironment, so to speak, right? So um because one of the primary ways that people do it right now is using mice and, really complicated and expensive equipment to injure the mice, and not everybody has that. So what phase one of my project was saying, okay, well, when you injure the mice, all you're really doing is, providing a blow or some sort of impact force to the head, right? And you can actually, turns out, get the same effect by um, applying sound waves. So, and just through like a speaker, if you apply sound waves, that those waves transmit in the same way that, an impact wave does, right? And that's, considerably cheaper than getting this like expensive equipment and whatnot. And instead of mice, I used the differentiated neuroblastoma cells, which behave a lot like neurons. um so yeah, that was first part of my project, was coming up with this way to simulate TBI in a more simple manner. And then the second part was really looking at mostly neuroinflammation and neuroinflammatory proteins and their expression um, after, I applied these sonic waves to them. Um, and we found that uh, there were certain inflammatory proteins that changed their expression that ended up having an impact on cell survival. So those proteins we then identified as, potential therapeutic targets for TBI. And the overarching theme of this project is just, you can do a lot with less, right? You don't need this big like um, fancy setup to assess traumatic brain injury. You can have, a very, very small apparatus, but still get some pretty striking results.
Yeah, thank you so much for talking about that. And that was really nice to hear about, like, how in depth you went early on. And now that you're, in college, and is there like, how do you feel about your current place? Like, do you feel that there's been a lot that you've learned about and you're excited to go forward? Or is there something about like the pandemic that's kind of, making it a bit
Yeah,
uneasy?
yeah, definitely a bit uneasy right now. Cause, first of all, to like where my place is in neuroscience, I feel like I've done some, but I haven't, you know, done nearly as much as, some of the more accomplished neuroscientists, right? Obviously. But and I'm still trying to like search for my niche in the field, right? And that's not something that's going to come for another few years, one after, because that usually comes during grad school and beyond. But speaking to the pandemic, yeah, like I think everyone who's doing lab work is feeling a little bit uneasy right now, just because a lot of us, for whatever reason, cannot access our lab spaces and things like that. So definitely the past couple months have been a little bit of worry regarding how am I going to progress in my research, because ultimately that is a very important factor in grad school sort of applications and things like that. So we're just but we're taking it like one day at a time, and we're just gonna find some remote work to do, and it'll turn out okay.
Like in terms of remote work, like what have you guys been doing now? Like
Yeah,
how does
so
it, oh yeah, continue.
mostly because the postdoc I work with, it's mostly a bench work project. So now really remote work just means literature reviews, right? Reading more about the project and preparing, presentations about what you read. So that's a really important and really common teaching tool that some labs will use, and it's really helpful. Hopefully, when we start to get some more data, hopefully then there's some data analysis component that I could participate in. But for now, it mostly literature reviews and preparing slides.
Okay, so that's great that there's still a lot of work that there is for you guys to do, and there's a lot of aspects about this field, so work never really stops.
Yeah.
But is there something about the field that you think that neuroscience needs more of?
Mm. I think I think something that because we're in such a great position now, I think, in the field, based on what I personally have experienced, where there are a lot of really, really bright people coming into the field, and some really, really cool work is being done. Just with every STEM field, I think the current issue is we need to encourage more let's say people of color, or generally underrepresented people, and female scientists as well, right? I think this is a conversation that's far greater than just the two of us, right? This is an international conversation, but yeah, within just any STEM field, this is an absolute necessity. And neuroscience, at least in my lab experiences, has been really good with that. Has been really good with seeking out people who are traditionally underrepresented in science, and I've had, an absolute blast working with, such a diverse lab. And because, within science, people bring different perspectives, and that's really important. So that's really something that I think we should keep striving towards. Um, I will say, between the two of us, some fields are doing better than others. Um, so there's definitely work to be done there. And in terms of scientifically, what neuroscience might need more of, I would like to see more work being done, at the intersection of the brain and the mind. So, there's like, for some reason, like just a divide between people working on neurobiology and then people working on, like more psychological or cognitive science. So I think what would be really cool is if, people could start, working together, and that's already happening. There's already quite a bit of work using like brain imaging techniques to figure out, like questions about like consciousness, which, is far too large for me to wrap my head around. But scientifically, that's what I think will be really, really cool in the future for neuroscience.
I love how you brought that up because that is something that I'm also genuinely interested about like the physical like brain itself and then the mind. And I think that's a very
Mm-hmm.
interesting, like cross section. And I would love to see more of it, together. And as you said, there's already a lot of work being done. But do you think with technology, there's a lot more that we can do in this field? Or do you think we have I mean, technology is always improving, but like, do you think that the field has been using technology pretty optimally as of now?
Oh, yeah. I think, like going back on what I said, there are a lot of like really, really bright computer scientists and mathematicians that are entering the field, and making use of, this really, really awesome technology that we have to help us solve these neuroscience problems. So, yeah.
And another thing that I think a lot of people like my age really are worried about is how do we get ourselves ready for such a challenging career in as a high school student. So in terms of course, I know you did a lot of like different science fairs and research opportunities, but yeah, but like expanding more on that, like as a high schooler, what can we do to really prepare ourselves and kind of see ahead that what we can expect about this field?
I would just say read a lot. If you have the means to do research, do as much of it as you can. Because the only way that you're going to know if you like it is if you do it, right? So yeah, go out, contact, professors, like, hey, I'm really interested in your work. Can I, sit in on your group meeting? Or, if you're looking to do work, be like, hey, this is the coursework I've done. I'm really interested in neuroscience. Would you consider me for a position? Um, and yeah, just go on, PubMed has, many, many, many research articles, and just read. One thing that's really great is that it's free, right? So it costs you nothing to educate yourself. If you want to, a textbook that's really good for general biology is Campbell. Read the neuroscience sections of Campbell. I think they're in there. Yeah, and or find another neuroscience textbook. It doesn't matter, right? Just know the basics, know what you want to do, um, or sorry, know the basics, and know enough to be able to maybe do some work if you want to. And I think you're well set up at that point, right? Because there's not much else. You can't say, oh, I'm gonna apply for grants and I'm gonna write research proposal. No, because like that's not what you do, right? You're a high schooler. You have to live your life. Um, so yeah, just read and do research if you can or if you want, right? And I think you'll be well suited. Oh, also maybe, you know, work on some interpersonal skills, just because in research it's really important that you're not just, you know, tunnel visioned at your bench. It's really important that you talk to people and that you network and form connections with people. So yeah, I think those three things are very important if you want to get a head start in, you know, a neuroscience career or a neuroscience interest once you enter college.
Oh, that's really good advice. And a lot of people do have those interests, but I don't think that anyone is really like, ready to go really in depth about this until like, and it's important to really make sure that you're like solidified your interest before you kind of go into this. I think that's really good advice. Also, were there any other activities you did besides like exploring your interest in neuroscience, and have they been like influential to you as a person and in general, like the way you work?
Yeah, I think one thing that I've done longer than I've done neuroscience is music. So I think that definitely informed my interest, because, you know, there's such a fascinating connection between music and the brain and how you perceive music. And that's partially where I got the inspiration for my project from, were, you know, these sound waves. And obviously music is just, you know, or like organized sound. Um, so yeah, definitely music was one of them. And then other things that I've done that, you know, maybe haven't had the biggest impact though are, um, I was always interested in um, oncology, so cancer biology. So I did some of that sophomore year. That was fun, but, you know, ultimately not, you know, my biggest interest. And you know, I just tend to know a lot of random things. So I did Quiz Bowl as well. Um, Learned a lot of stuff from that. Really cool. But, you know, not immediately relevant to my research. But, you know, it was fun.
Also, like being on such a diverse campus like Harvard, the connections you're able to form with other students. So by knowing people not just from like your field in particular, how has that like broadened your perspective about neuroscience and about a lot of things in general, I'd say.
Oh yeah, I think that's really helped. Um, it's really exciting to see so many people from so many different walks of life um, congregate, you know, on one campus, and, you know, the discussions that we have are absolutely incredible. Um, and, you know, it's like scientific training. It's like life training, right? You're never gonna agree. You know, it might be uh you know, you're never going to fully agree with somebody, but uh you know, it's good to have those stimulating intellectual discussions about science, about politics, about, you know, anything. And yeah, uh i think I think that that's definitely something that's going to influence my perspective on neuroscience, is that, like, you know, different people will have different views on things, and even something, you know, as rigid and factual as science, right? Like, people will interpret your data differently, people will interpret your conclusions differently, right? So definitely being around so many different people have really um impacted me and the way I see science and other things.
So as we come to an end, I just have like a final question. So do you have any like parting advice or anything you wish you did differently that you would like to reflect on?
um be, you know, be more open-minded. I think something that I didn't do enough of, like, I was pretty stubborn And I was pretty, I'd like to fit, or like I'd like to stay within my comfort zone. And I think something that might be helpful for people interested in science is, don't do that, right? Go out and explore maybe a random field that you would never have originally, right? Um, take classes in something that you don't think you're interested in, but maybe, maybe the professor's really cool, and you end up actually really liking it. And also, as high schoolers, I think it's really important for you guys, especially seniors, take time for yourself. Senior year, I don't know how it's going to look right this year, but senior year is really, really special. And, spend time with your friends, spend time outside, out of your house, out of your room, right? Away from your books. And just, yeah, I mean, I think I did the most socializing I've ever done senior year of high school. And, after it was over, I was like, why didn't I do more of that, the last, 4 years? So yeah, definitely it's not yeah, all about neuroscience. It's not all about science. It's not, it's, finding that balance between what your academic interests are and, still having, a social life. So that would be my advice.
Thank you so much for joining us
Absolutely.
today. I've honestly learned so much, and I'm so thrilled to have had this opportunity. And your story truly was an inspiring one. So thank you so much for joining us today.
Thank you, Isha. Thank you for having me.
Thank you.